So today we are going to study about gravity, sixth lesson, class 6, gravitation or gravitational force. Okay. Now this gravitational force is the pulling force, a force which attracts the object. It exists between every two objects in this nature. You can take any object, bigger to bigger object to smaller object. That is a force of attraction that is implemented by one body on another. The force implemented, a force of pull implemented by one body on the another. That is called as gravitational force. The force that exists between every two objects. Every two objects, your book and your pen, the force existing between your book and pen, the force existing between your anything you can consider. Okay, between tree or between tree and its leaves, force between tree and leaf, force between fruit and ground, all those forces. Okay, the forces which exist between any two objects in this nature, they are called as gravitational force, or that can be considered as gravitational force. Now among that, there is one special force existing. If out of two bodies that you are considering, if one body is earth, out of two bodies which you are considering for the experiment, if one body is earth, then that gravitational force which exists between the two bodies, this can be any body, you can consider anything, you can consider yourself, you can consider your book, pen, tree, planets, anything. Okay, if out of those two bodies one body is earth, then that gravitational force is specially named as gravity. That force is specially named as gravity. Otherwise, in general, it is called as gravitational force. But if out of two bodies, one body is earth, then that force, that gravitational force will be special, that has a special name called as gravity. Gravity is also gravitational force, but only when one body out of the two is earth. Okay, then that is gravity. Now, let us study about another concept, acceleration due to gravity. So we know what is gravity. It is the gravitational force where one body out of two is earth. What is acceleration due to gravity? Whichever body is of heavier mass, it will implement more force on the body which is lighter mass. If in this example, if I am considering this as earth and this as you, okay, or any human body, okay, then here which one's mass is more? Earth's mass is more. So earth will be implementing force on human body, or earth will be implementing the force on this object. Okay, because the mass of this one is lesser, the mass of this one is higher. Whose mass is higher, they will implement more force. So the body with a lighter mass will act under the influence of the body with the heavier mass. So this will act according to the wish of this body. Okay, so the force of attraction of earth attracts the human body towards the earth. This body will act according to this one because its mass is lesser than the mass of earth. Okay, then this will move with accordance to earth. Now with what acceleration it will move towards the earth, or it is implementing force of F, let us say. So it is m into a. Force is equal to m into a. M will be the mass of the object. A will be the acceleration implemented by this body here, which is earth, on this one. Acceleration implemented by earth on the body. This acceleration which is implemented by the earth on another body is called as acceleration due to gravity. And that A is represented by G. So, you have to be careful. Gravitational force is not G. Gravitational force is F. Okay, general representation force F. Acceleration with which the body acts when one body is earth under gravitational force, that acceleration is represented by G. It means if the gravity is acting between two bodies, the lighter body or the lighter mass moves under the influence of gravity, then with what acceleration the lighter body moves under the influence of gravity, that acceleration is called as g, or acceleration due to gravity. It is generally assumed that the g value is constant and that value is considered to be 9.8 meters per second square. The g value varies. It is true that the g value varies, but to a very small extent, like 9.81, 9.82, like this. So it is rounded off to 9.8. We can say the g value, which is considered to be constant, it is rounded off to 9.8. In some cases even they take 10, but it should be given that g is 10. Only then in sums you can take g is equal to 10. Otherwise we round it off to 9.8. In some cases they will give you the value as g value is 9.82, then you have to take 9.82. So because g can vary, the value of g can vary, but we can round all, but because the changes are very minute, the value of g varies with a very minute quantity, we can round it off to 9.8. So g is 9.8. Now next concept, we will study a little bit more about the characteristics of g. The characteristics of g. Okay. First one, g does not depend upon mass. It is not dependent upon the mass. You can consider any planet moving under the influence of gravity, or any bigger body, mass body moving under the influence of gravity, or the smaller body moving under the influence of gravity. Both are moving with the acceleration of 9.8. So it does not depend upon whether the body's mass is higher or lower. Both higher and lower body. A feather also moves with the same 9.8 meters per second square. If there is no other forces implemented on it, only gravity is acting, then it also moves with the 9.8. The building also moves with the acceleration of 9.8 towards the center of earth. Both feather and a big building, consider two examples here. Feather and big building both will move with the same acceleration of 9.8 meters per second square. Okay, so it is not dependent on the mass. That is the first point. The second one is the value of g varies with height and depth. The value of g varies with the height and depth from the surface of the earth. If this is the surface of the earth and g I am considering here to be 9.8, then with the increase or decrease height or depth, the g value varies. Okay, it is said that with the height or depth, g value decreases. It decreases. Okay, it decreases. So as height increases or depth increases, g decreases. G decreases. G decreases with height or depth. As height increases, g value goes on decreasing. As depth increases, g value goes on increasing. This is the second point. With height and depth, with the height and depth increasing, g value decreases. Okay. Now the third point is that with the equator, from equator to pole, g value increases. From equator to pole, equator is this one, poles are this one, right? From equator to pole, g value increases. Okay, from equator to pole, g value increases. This is the next point. Okay, next characteristics. Okay, then we have the value of g can be positive, negative or 0. Let us see in which cases it will become positive, negative and 0. If this is the ground and if there is a body here, and if it is falling under the influence of gravity, means towards the center of gravity, okay, towards the center of gravity, it is moving in the downward direction, then g value will be positive because it is acting along the gravity, But if the case is body is moving upward against the gravity, if the body is moving upward against the gravity, then g value will be negative. What about the body which is at rest? It is not moving, then g becomes equals to 0. G is acceleration. Body is at rest means there is no acceleration. Body is at rest means there is no velocity. There is no velocity means there is no acceleration. Okay, so g becomes 0 when body is at rest. It is the g will acquire the value only when it is moving. Okay, so we say at the surface of the earth. At the surface of the earth means it is at rest at the surface of the earth. Then g becomes equals to 0. When it is above the surface of the earth or below the surface of the earth, then g value of that object will vary depending upon the situation, depending upon the problem given to you. Okay, so last one, another point, that the gravitation force, acceleration due to gravity, the value of acceleration due to gravity on moon is 1/6 times the value of acceleration due to gravity on the earth. Okay, so the value of acceleration due to moon, what the force exerted by the moon on you, if you are standing on moon, the force exerted by moon on you is 1/6 times lesser than the force exerted by earth on you. Okay, so the weight of you will be 1/6 times lesser on moon when compared to the weight of the body on the earth. Okay, so these are the different characteristics of acceleration due to gravity. We will study the next concept in our next session. Okay, thank you.